November 2019 HL Paper 2, Question 3. The diagram shows the graph of y equals to fx between -3 and 5. Find the value of f of 1. Okay, so this notation is a little not so nice. I prefer to write it in this way. I basically evaluate what f of 1 is, okay, and I take that value and I evaluate into f again. So let's read the graph. F of 1 is 0, okay, because when x equals to 1, y is equals to 0. So this is the same as evaluating f at 0. So now what I do is I take the x-axis, I pinpoint where 0 is, and I locate the value of y at x equals to 0. And that answer is -1. Part B. Given that f inverse of a is 3, determine the value of a. So this is equivalent to saying that f of 3 equals to a. Okay, so I'm going to look for 3 on this graph. I'm going to read off the graph to find the value of a, which is 4. So therefore a equals to 4 from graph. Part C, given that g of x is 2 times f of x minus 1, find the domain and the range. Okay, so this is a transformations question. We note that f of x minus 1, this is a translation of the graph by 1 unit in the positive x direction. So the graph of f of x minus 1 really looks like this, okay, something like this. We are going to take this graph, move it to the right by 1 unit. Okay, so everything gets shifted, okay, to the right by 1 unit. So the domain also gets shifted to the right by 1 unit. So instead of -3 to 5, now it's -2 to 6. Okay, so that's the new domain. Right? So the graph of G is a translation, okay, of f by 1 unit in the positive x direction. So therefore the new domain, okay, or rather the domain of G is x between 2 and 6. Now we haven't done the times 2 yet, okay, so what that does is a transformation where it is a stretch parallel to the y-axis by a factor of 2. So the -3 here will go down to -6. The 5 here will be multiplied by 2 to get to 10. Okay, so and alright, a scaling or stretch, okay, by a factor of 2 parallel to the y-axis. So the domain of the range, so the range of G is going to be -6 to 10. And that's the answer.